Hello, Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Asfa bin Muhammad Zamri, S71742, and today I'm going to talk about corrosion protection and what type of corrosion protection that I choose to explain. Right? So, what is corrosion protection? Corrosion protection refers to the method and technique used to prevent or reduce the deterioration of material, particularly metals, due to chemical reactions with their environment. Corrosion is a natural process that occurs when metal react with moisture, oxygen, acids, salts, or other corrosive agents, leading to the formation of rust or other degradations. These are several common methods of corrosion protection, including coating, cathodic protection, galvanization, environmental modification, and lastly, design improvements. So, we're gonna talk about coating, cathodic protection, galvanization, environmental modification, and design improvement. Okay, firstly, we're gonna talk about coating. What is coating? Coating is a substance applied to the surface of an object. It can serve as decorative or protective purpose or both. Protective coating play a key role when it comes to corrosion protection. By applying protective coatings such as paint, varnish, or specialized corrosion resistant coatings, for example, epoxy, polyurethane, polyurethane, to create a barrier between the metal surface and the environment. Okay, so next is cathodic protection. This technique involves putting a sacrificial anode made of zinc, magnesium, or aluminium near the metal structure. The sacrificial anode rusts instead of metal we want to protect. By controlling the flow of electricity, cathodic protection stops rust from happening, making sure the metal thing lasts longer and stays strong. Okay, the third one is galvanization. Galvanization is a method where we cover metal with a layer of zinc to stop it from getting rust. The zinc layer works like a shield, protecting the metal underneath. Even if the zinc layer gets damaged, it still protects the metal. This process helps metal objects last longer, especially when they are exposed to tough conditions like weather or chemicals. Okay, the fourth one is environmental modification. By changing the environment by adjusting temperature, humidity, or pH level to reduce the corrosive agent's concentration. Last but not least, design improvement. Did you know by using material and designing things can resist rusting? Things like making sure water can drain away properly, having enough airflow, and using materials that do not rust can make stuff stay longer. Engineers use this measure while designing things as it helps in stopping rust. So, from all five corrosion protection, I would love to choose coating and talk about it more. They are statements from Qian and Feng 2015. The metal surface may be coated for protection against corrosion. Most of these coatings perform as barrier between the metallic surface and corrosive environment, and therefore this method is called barrier protection. And did you know there are five types of coating? So firstly, there are organic coating. For description, these coatings are composed of carbon-based polymers and provide effective barrier protection against corrosive environment. And second, it was inorganic coating, such as metal oxide or ceramics, offer excellent resistance to high temperature and harsh chemicals. So third coating is metallic coatings. including alloy-based coating, provide sacrificial protection by corroding prefacially to the underlying substrate. So the fourth one is ceramic coatings, known for their high hardness, thermal stability, and resistance to wear and corrosion. So the last one is hybrid coatings, combine organic and inorganic components to achieve synergistic corrosion protection and enhanced performance. There is mechanism of corrosion protection offered by coatings. The mechanism underlying corrosion protection coatings effectiveness are contingent upon their specific type and composition. This mechanism encompasses a range of strategies including of barrier effect, sacrificial protection, and self-healing properties, each of which address corrosion challenge through distinct mechanisms. Firstly, barrier effects. The barrier effect, a fundamental mechanism employed by various corrosion protection coatings, involve the creation of physical shield between the substrate material and corrosive agent. By forming this barrier, the coating impedes the diffusion of moisture, oxygen, and other corrosive substances, thereby effectively isolating the substrate from its deleterious environment. Through, uh, through the inhibition of direct contact between the substrate and corrosive agent, the barrier effect mitigates the corrosion rate, consequently extending the coating material lifespan. So, sacrificial protection. Another pivotal mechanism is sacrificial protection, often observed in coatings containing metals with a higher electrochemical potential than that of the underlying substrate. In the presence of corrosive agent, these coatings function by intentionally corroding the sacrificial metal layer. The sacrificial corrosion process safeguards the substrate select as the corrosive agent selectively attacks the sacrificial layer, thereby impeding the degradation of the substrate material. This mechanism proved especially advantageous when the coating structural integrity might be compromised, such as in cases of scratches or minor damage to the coating film. The third one is self-healing properties. Certain certain corrosion protection coatings offer an innovative self-healing mechanism. Within this coating, additive or components are integrated that possess the ability to autonomously repair themselves upon sustaining minor mechanical damage or scratch. When these coatings are subject to such damage, the incorporated healing agents are triggered, initiating a restorative process within the affected region. The self-healing capacity of this coating ensures that even the presence of small defects or breaches in the coating film, ongoing protection is sustained. This property is particularly valuable as it mitigates the potential impact of localized defect on overall corrosion protection. Collectively, this mechanism exemplify the diverse approach adopted by corrosion protection coating to counteract the corrosive force that threaten materials. The combination of barrier formation, sacrificial protection, and self-healing properties equips the coating with multifaceted strategies for ensuring the prolonged integrity and durability of material across various environments. So, by applying a protective coating to metallic surface is the most effective method to mitigate corrosion damage. According to a National Association of Corrosion Engineers, NAC report, more than $100 billion is spent in the US to control corrosion by the application of either organic or metallic coatings. Okay, from the table we see Initial lifetime is 10 years, and the final percentage of breakdown is 20%. For the 40 years lifetime, the percentage of coating breakdown is 90%. There are few common testing methods such as salt spray test, electrochemical technique, and accelerated weathering. Common testing methods are employed to assess the performance of corrosion protection coatings. This method evaluate key properties such as adhesion, corrosion resistance, mechanical strength, and barrier protection. So, what is salt spray test? Salt spray test is a widely used accelerated corrosion test that assess the coating resistant to corrosive environments. So next, electrochemical technique. Electrochemical methods such as corrosion potential measurement and electrochemical impedance spectroscopy (EIS) provide valuable information about the coating performance and corrosion resistance. So lastly, accelerated weathering. The test stimulate environment conditions such as exposure to UV radiation and moisture to evaluate the coating durability and resistance to degradation. So from this graph, we see it is obvious that highly effective coating costs more. When the coverage of coating is less than approximately 80%, there is a linear relationship between cost and percent of coverage. However, if a high degree of coverage is demand, this becomes a logarithmic relationship. In conclusion, coatings have proven their efficacy in protecting critical infrastructure, enhancing the lifespan of automotive components, and ensuring the reliable operation of renewable energy systems and aircraft structures. However, emerging sectors present unique challenges and opportunities, requiring specialized coating compatible with new materials and technologies, while also meeting stringent environmental and sustainability standards. Looking ahead to the future of corrosion. Okay, thank you for listening to my talk and goodbye. See you next time.